Our today's topic is how to calculate the area of a sector. So before we go into it, let's define some of the definitions what we are using. So now this is a circle and having different parts. As you know, in a circle it is a center, and then there's another point. This is stationary and this point is moving, keeping same distance from another point, that is called center. So this length is called circumference of a circle. Now the line joining these 2 points, or distance between these 2 points, one is stationary and one is moving, is this. This is called radius, the radius of a circle. Now the part of this circumference, if I take this part only from here to here, this part is called arc of a circle. So here you can see that this is the arc of a circle. So we can say it minor arc. This is small portion is called, sometimes you can call it minor, and this you call major. Minor arc and major arc. Now another thing, we are having a chord. You take any 2 points on the circumference and you join them. Any 2 points, whether it is this or this or this, any 2 points is called a chord. So this is a chord. The end of the chord, they lie on the circumference of the circle. And the diameter is also a chord, and diameter is this is a chord and this is a diameter. So diameter is largest chord, and diameter is 2 times radius. The line joining center and the circumference is a radius, and line joining 2 points on a circumference, either passing through the diameter or not passing through the diameter, is called a chord. If it is passing through center, it is called diameter. Now there is another line that is cutting the circle into 2 parts. That is called secant, not sectant. That is secant. Its endpoints never lie on a circle. So it cuts the circle into 2 parts. Then these parts are called segment. If this is a circle, I cut it into 2 parts, and one part is this, another part is this. This is called segment. Big part is called major segment, and a small part is called minor segment. And if the line is just, this line is dividing into 2 parts, but if line touches only at one point, this line is called tangent. So tangent is touching a circle only at one point, that is just touching here, and segment is segment is this area. This part is called the segment. And most important is the sector. Sector is the area of a circle, the part of a circle which is made by two radii and one arc. So this is called sector and this is called segment. The difference between sector and segment is sector is a kind of a triangle made up with two radii, and segment is just a cut portion of a circle, that is called segment. So here we are going to learn the area of this portion and the area of this portion. Now if I have a circle and this is the sector, this is the sector of a circle, and if the radius is r and this angle is theta, and I have to calculate the area of this portion, then it will be, this is r, this is r, this is theta, and theta is in radian. So area of sector is equal to half r square theta. This is a very easy formula. And very important. So we are going to use this formula to calculate the area of a sector. R is length, meter, centimeter, kilometer, whatever is there, and theta is in radian. Now the question is the arc AB of a circle and center O. This center is O, this is A and B, and these are the radius. This is not very accurate. Radius 6 centimeter, this is 6, this is 6, has a length of 4 centimeters. So this length is this length is 4 centimeter. Find the area of the minor sector. Now this is the minor sector. And the upper one is a major sector. This is a minor sector. So area, we have to find the area. Now we know that area of a sector is equal to half r square theta. Now we don't know what is this theta. We know r is 6, but this theta is not, but we know this length. Now we know that the length of an arc is equal to r theta. It means L is equal to r theta. So from here theta will be L over r. So theta will be L is 4 over r is 6. So that is 2 over 3. So this theta is 2 over 3 radian. So the area of this sector will be half r square is the radius is 6 and theta is 2/3. So it will be equal to 36 multiply 2/2 multiply 3. 2 and 2 cancel. So that is 12, because the length is centimeter. So this is 12 centimeter square is the area of the sector given. Now there is another question. The arc of a circle with center O and radius x. Let's say this is x and this is x, that is the radius of a circle, is that angle AOB is a pi/12. This angle is pi/12. Given that the arc length AB is L, even this length is given as L. Show that the area of the sector can be written as. Now for the area of sector, we know our formula is half r square theta. So that is equal to half r, we have x square, and theta is pi/12. So that is pi x square over 24. But we have to write this in terms of x. Now let's find the relation between L and, we know the formula is L is equal to r theta. So this means L is equal to r is x theta. So it shows that x is equal to L/theta, and theta is pi/12. So L/pi/12. So that is equal to 12L/pi. That is the value of x. We put this value of x here. Pi. This is x is pi x square, 12 square L square over pi square multiply 24. So area will be, this is pi 12 square L square over pi square and 24. 12 square can be written as 12 multiply 12. So 12 times 2 is 24, 2 times 6 is 12. Pi and square cancel. So what is remaining is, what we have is 6 L square over pi. So our answer is 6 L square over pi. So area of sector is 6 L square of pi. The only thing we have to consider here is, what we have to prove here is 6 L square over pi, and there is no L here. So you have to convert or find the relation between x and L. Once you find you write the formula, you take the value of x and put the value of x here in terms of L. You will get the answer. This was part A. Now part B is, the area of the full circle is 360 pi square. This complete. Find the arc length of AB. Means you have to find this L. if this is a complete area of the circle, complete area is, so area of circle is, our formula is half, no, it's giving the complete area of a circle, full circle. So area of the full circle is, so we divide it into two parts. This is theta 1 and this is theta 2. But we already know that theta 2 is equal to 2 pi minus pi over 12. So this is 24. So this is 23 over 12 pi. This one. So r theta 1 plus half r theta 2, r square. So that is equal to half r square theta 1 plus theta 2 is equal to 3600 pi. So that is r square is equal to 3600 pi multiply by 2 divide by 2 pi. Theta 1 plus theta 2 is 2 pi. Pi cancel, 2 and 2 cancel. So r is equal to root 3600. So that is 60 centimeter. So x or r is equal to 60 centimeters. Find the arc length of AB. So arc length AB is equal to L is equal to r theta, that is equal to 60 multiply pi over 12. So that is 5 pi. So arc length of AB is 5 pi. To calculate the value of x, x is the radius. We have already calculated x, 60 centimeters. Now how to calculate the area of a segment? Now this is a sector of a circle. O is the center and AB is the minor arc. So this is a sector. So we know that the area of sector is equal to half, if this is r and this one is theta in radian, so that is half r square theta. This is a complete area. Now we have a triangle here. This is a triangle. This one is a triangle. So if we remove this triangle from here, then we'll get this. This is segment. This portion. So this portion is a segment. So if I subtract the area of a triangle, so let's calculate area of a triangle. You know that the formula for area of a triangle is half AB sine C. Sine C is angle between A and B. So these are two sides, so that is half r square sine theta. Now which one is bigger? Sector is bigger, so if we subtract the area of sector from the area of a triangle, we will get the area of segment. So the area of segment is area of the segment is equal to area of a triangle, that is half r squared theta minus half r squared sine theta. If you solve it, this is simplified. Half r square is common and the balance is theta minus sine theta. So that will be the formula for the area of a segment. So this is a question, this is an important question. It says that this figure shows a semicircle. So this is a x and y, and O is the center of the circle, and the radius of this circle is 3 centimeters. So this is 3 centimeter, the radius of the circle. XY is the diameter of this semicircle. The point Z is on the circumference. This is a point Z, it is on the circumference, such that angle XOZ is 1.3. XOZ, this angle is 1.3 radian. The shaded region enclosed by the chord XZ, arc ZY, and the diameter XY is the template for a badge. This is the template for a badge. Find giving each answer to 3 significant figures. So you have to answer in 3SF. Question number 1. The length of chord XZ. We have to find this one. Now this is we can see that this is a triangle where this is given 1.3 and this side is 3, this side is 3. Two sides are given, angle between them is given. So to find the third side, we use cos formula. So the cos formula is xz square is equal to square of this side plus square of second side minus 2 multiply one side multiply second side and the angle between them, that is cos 1.3. Now always remember, this is the angle between these two sides. This is the angle between these. This formula starts with this length and ends with this angle. So that is equal to xz square is equal to, this is 9 plus 9, 18 minus 18 cos 1.3. So if you simplify in your calculator, you will get xz is 13.18, so it is 3.63 centimeters. So that is the answer of the first part, the length of this chord. Now we move to second question, question number B. The perimeter of the template XZYX. The perimeter of XZYX. Perimeter of the template. So we have xz plus zy plus xy. xz is a line plus zy is a curve plus xy is a line. Now what we have here is xz. We have already calculated 3.63. xy is a diameter, so that is 3 plus 3, and the only thing we have to calculate is this length, zy. So length of arc zy. Our formula is length is equal to r theta. So r is 3, and what is this theta? This total is pi, and this is minus 1.3. So 3 and pi minus 1.3. That is simple. R theta is 1.3. So that will be equal to 5.52. So this is 5.52. So our answer is 3.63 plus 5.52 plus 6. So that is equal to 15.15. So that is equivalent to 15.2 centimeters. So the perimeter of template is 15.2 centimeter. And the next is the area of the template. Now to find the area of a template, first we have to find, let me draw a rough figure here. Now first we have to find the area of this. Now what will be the area of this? This area of this sector. So number 1, area of sector this sector. This is a sector, this is 3, this theta is, so it is half r square theta. So that is half r square is 3 square, and this is pi minus 1.3. So this is equal to 8.287. Centimeter square. So this area is 8.287. Now what is this area? The area of sector, this is a segment now. So second is area of segment. So we know the formula is half r square theta minus sin theta. So that is equal to half r is 3 square. Now theta we are going to use this angle, that is 1.3 minus no, we are not going to find, we have to find the area of the triangle, not area of segment. This is a triangle only. This is a triangle, this is not a segment. So we are not going to use this, the area of a segment. What we are going to use is we are going to use is the area of triangle. So area of triangle is half A B sine C, sine 1.3. So this is equal to 4.336. So if you add it, so the area will be 12.623. So that is equal to 12.6. So that is the area of triangle. Thank you very much for watching. If you have any question, please do ask me.